Hello everyone and welcome to this brand new video in which we are going to learn about data representations for neural network. In this video we are going to learn about the different types of tensors and the different types of datasets like image dataset, time series dataset, and how they are represented. And I think it's a very basic building block if you're getting started with neural network. So have fun. So in the previous example, we have shown that data is stored in a multidimensional Numpy array called tensors. But what exactly are tensors? So tensors are containers for data and usually numerical data. And you are already familiar with matrices. So in the previous example that we saw, we had 28 cross 28 images and we flattened them into one vector. So this is like high school stuff. And then this data was input to the neural network. So the vector was actually represented by a matrix because you have the number of samples and the features. So today we are going to take a look at different kinds of tensors. So we have rank 0 tensors, which are also known as scalar, and it's nothing but just a number. So if I just write import numpy as np and I create an array of just a number, np.array 5, and you can check the dimensions of a array using so we have to just keep a number. So using .ndim attribute. So if I say x.ndim, it will be 0. So this is a rank 0 tensor, also known as scalar. Then we come to vectors, and vectors are rank 1 tensors. So what happens in vector? You have a list of numbers represented as an array. So 5, 6, 10, 1, 2, whatever. And the ending for this will be 1. So here we have, here the author says that the vector has 5 entries, and so it's called a 5-dimensional vector. And if I have one more entry here, then it will be a 6-dimensional vector. 1, 2, 3, 4, 5, 6. But ndim is going to be just 1. So you don't have to confuse a 5-dimensional vector with a 5-dimensional tensor. So just keep that in mind. 5-dimensional vector is not 5-dimensional tensor. A 5D vector has only one axis and 5 dimensions along its axis, whereas a 5D tensor has 5 axes. And what is axis? We will come to that. And the idea of axis is very easy to understand if you have a matrix. So let's say instead of one list, you have a list of values. So it becomes a matrix, and now we will represent it in a better manner. So something like this, and inside this you can have multiple lists, right? So 1, 2, 7, 45, 5, 6, let's say, and I add one more, 0, 1, -1, 10, 11, 77, something like this, and I create an array. So now my array looks something like this, just what I have input, and now this is called a matrix. And a matrix has 2 axes, row and column. So the first axis is row and the second axis is called column. and the ndim for this one will be 2. So that's your matrix, and the matrix is something that we used in our previous example where we had 60,000 rows and 28 times 28 columns. So 60,000 cross 784. So you have 60,000 rows and 784 columns. That was our MNIST example when we flattened the data. Okay, so this is your first row and this is your first column. And now we come to rank 3 tensors or higher rank tensors. So in higher rank tensors, you can have matrices which are stacked. So you can visually interpret as cube of numbers. So you have one matrix, you have another matrix, you have another matrix. And that's what is happening here. See, we have one matrix, we have another one, and we have another one. So what is this like? It can be an image. You have 3 matrices representing one image, RGB. I don't think the last one is visible, so let me just draw it here. RGB. So if you pack this rank 3 tensor in an array, you will create a rank 4 tensor and so on. So a tensor is defined by 3 key attributes. The first one is the number of axes, which is the rank of a tensor. So a rank 3 tensor has 3 axes and the matrix has 2 axes. Matrix is rank 2 tensor, and which is tensor's ndim. The second key attribute is shape. So if you want to find the shape of an array, you just call dot shape. So here, if I find the shape of X, it will be 3, 6 because it has 3 rows and 6 columns. And the third one is data type. So data type implies what kind of data is stored in the tensors, usually called D type in Python libraries. So you can have float 16, float 32, float 64, uint 8, long, things like that. If you want to check D type of a tensor, you just type x.dtype. And here we have integers, so you get D type as int64. If I add 5.5 instead of 5, my D type changes to float64 because now it's a float tensor. So all values are stored as floats. So it says to make this more concrete, let's take a look at the data we processed in MNIST example. So let's import the MNIST dataset from tensorflow.keras.datasets import MNIST. And here we have train images, train labels, and test images, test labels. This is your MNIST.load dataset, load data. Okay, so let the data load. So now we have the dataset, and I can do train_i, which is train_images. You see an array. And if I check the ndim for this, I get 3. So there are 3 dimensions. Let's check the shape. Train underscore I dot shape is 60,000, 28, 28. So you have 60,000 images and each image is of size 28 cross 28. So each image has 28 rows and 28 columns. And we can also check the D type. Train images dot D type will be, we don't need the brackets, uint 8. So what we have here is rank 3 tensors of 8-bit integers. More precisely, it's an array of 60,000 matrices of 28 cross 28 integers. Each such matrix is a grayscale image with coefficients between 0 and 255. And it's also very easy to check. So if I do np.max of train underscore I will get 255, and np.min of train underscore I should be 0. So that's what you get, 255, 0. So now it says, okay, let's try to display the 4th digit of this rank 3 tensor. So this is a rank 3 tensor because it has 3 dimensions. Because ndim is 3. So let's import matplotlib. Import matplotlib.pyplot as plt. So we will be using matplotlib a lot. And our digit is train underscore I 4. That is the 4th digit. So if I look at digit, it looks something like this. And digit.shape will be 28 cross 28 and dim is 2. Now if I have to show it, I will just write plt.im show digit, and I will choose a color map equal to plt.cm.binary, and here I can write plt.show. So this will show me the digit. So that's the digit 9 that you also see in the book here. And similarly, I think we have also done this in the previous video. So if you have train labels, and the 4th label should be 9 because it's training labels. And same for test labels. But when you train a neural network, this can be a different number if your neural network is not very good. The next part that we come to is manipulating tensors in Numpy. Numpy. So what if we have to select digits from number 10 to number 100, and number 100 is not included? So if we have to select digits from number 10 to 100 and put them in an array of shape 90 cross 28, 90, 28, 28, I will say, okay, I will create a slice. The operation is known as slicing. Train images and take all numbers from 10 to 100. And when you take a look at my slice dot shape, you have 90 images of 28 cross 28 each. This can also be represented by something like this, where you are not slicing anything for the 2 different axes, and the shape will remain the same. You can also write it like this. So the first one is considered to be 0, or you can also write it like this, and it's going to be the same. So all these 4 or 5 operations are the same. So if you have to select 14 cross 14 pixels at the bottom right corner of all images, what would you do? So we start from this. We select the first 90 images, and we have to select bottom 14 cross 14. So let's select all images, and we can write start from 14th row, go to the end. Start from 14th row, go to the end. Or we can also write 14 colon 28. So now this has selected. Now my slice dot shape should be 60,000 14 cross 14. Let's take a look at our example again. I will take the digit from my slice now, and we will plot this. So there are a few things which is not there in the book, and I think you should definitely try it on your own. And this is selected the bottom right corner of this image. As you can see, this is the bottom right corner of this image which has been selected. Okay, great. Now, what if you have to select 14 cross 14 pixels centered in the middle? How would you do that? So for this, one of the easiest things would be to use negative indices. So much like negative indices in Python list, they indicate a position relative to end of current axis. So I will start with 7. So now my slice will change to 7 to -7. And I know these values because the image is of 28 cross 28. So if it's in the middle, it should start from 7. 7 to -7. And then this is your new slice, and the shape will be same 14 cross 14. If you want to display the same image, select the fourth one and let's display it. And you see this is the middle part of the image that has been selected. So when you're dealing with images, you will probably use these kind of operations quite a lot in the augmentations part. But yeah, we will come to that later. Augmentations, where you select only some part of the image for training. So the next thing that we come to is data batches or batches. So here it says, in general, the first axis in all data sensors you will come across in deep learning will be the samples axis. So the first axis is always going to be samples. So here also we saw that we have 60,000 samples. And then comes the data most of the time. So if I take one batch of data with a batch size of 128, what can we write? It's just a slicing operation. Batch, if the batch size is 128 and we take the first batch, we can write train underscore images 0 to 128. So this gives us the first batch of data. Our batch size is 128 and we have 28 cross 28 images. If we have to select the next batch, we can do 128 to 256. We just add 128 again. And if we have to select the nth batch, so our n is 5, and here we can write 128 multiplied by n multiplied by n, and we go till 128 multiplied by n plus 1. It's very simple mathematics. And this here you have the fifth batch, or you can find any nth batch, and that's what is shown here. So one thing that you will encounter frequently is batch axis or batch dimension. And the first axis, the axis 0, is called the batch axis. So here 128 is the batch access. Now let's see some real world examples of tensor data or data tensors. So first one, vector data. You have rank 2 tensors of shape, samples and features, where each sample is a numerical attribute. Where each sample is a vector of numerical attributes. So it can be a very simple data set. We will see some examples, but let's first see what are the different types of data sets. Another example is time series or sequence data, where you have samples and then you have time steps. And then you have, for each time step, there is a feature. So vector data we have seen in the previous example when we converted our image dataset to vector dataset. Time series data we have not seen yet. Images we have seen, but we have not applied them to neural network. So images are samples, height, width, channels. Now when we are talking about MNIST dataset, it's a grayscale image with only one channel. Generally you have 3 channels RGB, and thus this value is 3, and you have some height and width and you have number of samples. But when you have only one channel, you don't need this channel's access anymore. And then you have video, which is rank 5 tensors of shape, samples, frame, height, width and channel. So how do we, so now we can take a look at what vector data really means. So it's the most common use case. If you're familiar with dataset like Titanic, you can say it's vector dataset because you have a sample, and for each sample you have a vector of features. So like age, sex, cabin, and blah blah blah. So every sample is represented by a vector of features. Another example that has been shown here is a data set of text documents where we represent each document by the counts of how many times a word appears in it. So if you have 20,000 common words, each document can be encoded as a vector of 20,000 values, and each value is a count of how many times it appears. So if you have 500 texts, and then you have 20,000 features. So here one sample would be, let's say this is word 1, word 2, word 3, and so on. Here you can say 10, word 1 appears 10 times, 0 times, 1 times, 5 times, and so on. So each sample becomes a count of words features if you have 20,000 words. And that's like one of the most basic approaches of dealing with text data sets, NLP problems that we will also see in near future. So the next example is time series or sequence data set. So this is a very interesting example. And in time series, you have samples, obviously, and for each sample, you have a number of time steps. And for each time step, you have features. So the time axis is always the second axis of index 1 by convention. Let's take a look at data set of stock prices. So for every minute, we store the current price of the stock, the highest price in the past minute and the lowest price in the past minute. So for every minute, we are storing 3 features. 3 features. One is the current price, one is the highest price past minute, and one is the lowest price in the past minute. So every minute is encoded as a 3-dimensional vector. An entire day of trading can be encoded as a matrix of shape 390, 3. There are 390 minutes in a trading day, and 250 days of worth of data can be stored as a rank 3 tensor of shape 250, 30, 390, and 3. So if it's 250, 390, and 3, so let's take a look at 390 and 3 first. So we have 390 minutes of data. We have 3 features for each minute. So if I index it, if I do the slicing, if I say give me all features for 0th minute, I will get a vector of 3 features. Right. And this can be expanded if there are like 250 trading days. So now each day of data is represented in this matrix. So now these become the feature for each day. So I can say give me the 0th day of data. So something like this, and I will get a matrix of shape 390 cross 3. So that's how you represent time series dataset. There is another example, and I won't go through this one. Take a look. It's also very simple and easy example. The next type of data that we can come across is image dataset. We have already started with image dataset, so I don't know if I should really go into like depth of this, but it's very simple to understand. If you have a grayscale image, and let's say you have 128 images, and each image is of the size 256 x 256, and this is a grayscale image, so you have one channel. So this dataset can be represented as 128, 256, 256, 1. And this can be simplified as 128, 256, 256. If you have 3 channels, so you have 3 matrices, and now these 3 matrices will come here. So here, instead of 1, you have 3. Okay, so there are 2 conventions for image tensors. The channel last convention, which is standard in TensorFlow. So we will keep our discussion to the channel last convention. In PyTorch, it's channel first. So we have samples, height, width, and color depth. So this is samples, height, width, and channels or color depth. Great. So now we have learned quite a lot, and the last type of data that we can encounter is video data. So video data, if you understand image data, it's pretty easy to understand video data. So here you have, in videos, you have frames. So each frame can be stored as a rank 3 tensor height, width, and color depth that we have already seen. So here you have frame. Frame is height, width, and color depth. And a sequence of frames can be stored as a rank 4 tensor. So you can now say frame sequence of frames is my frame number, and then height, width, and color. Great. And if you have a number of samples, so here we had 128 samples in the image, we had 128 images. So a sequence of frame is nothing but a video. And if you have multiple videos, you add one more dimension to it in the beginning. So that's what is written here. You have samples, then frames, then height, width, and then the color depth. So if you have a 60-second YouTube video, which is of the resolution is 144 cross 256, and you have 4 frames per second, you have 240 frames, 4 multiplied by 60, so 240 frames. A batch of 4 such video clips would be stored in a tensor of shape 4, which is your batch size, frames, height, width, and channels. And that's it. Now you understand the different types of data tensors and how they can be used, how they are represented. And this is very important if you want to get started with writing your own neural networks. It's important to understand all this. And I say that's it for today's video. And in the next part, we are going to take a look at tensor operations. And till then, goodbye. Thank you very much. If you like it, do like and do subscribe and share with your friends. See you next time. Bye.